Hello there, and welcome to a journey through deep time. Tonight, we're drifting backward through billions of years to explore the most soothing secrets of ancient Earth. A world so different from ours that it feels like visiting another planet entirely. We'll discover landscapes that existed long before the first flower bloomed, oceans that sparkled under alien skies, and continents that wandered the globe like sleepy giants. Some of these facts will feel familiar, like whispers from a half-remembered dream. Others will surprise you with their gentle strangeness, but each one will carry you deeper into the quiet rhythm of geological time, where mountains rise and fall like slow breathing, and entire eras pass in the space between one heartbeat and the next. If you enjoy these peaceful journeys through science and history, feel free to like and subscribe, or simply share your thoughts in the comments below. It helps others find their way here too, but for now, let your breathing slow, your mind soften, and allow the ancient Earth to wrap you in its timeless embrace. Let's begin our descent through the layers of time. Long before there were forests, there were strange gardens of stone. In the earliest chapters of Earth's story, around 3.5 billion years ago, the planet was decorated with structures that looked almost like coral reefs. But these weren't built by any animal. They were the patient work of some of Earth's first life forms, tiny microorganisms called cyanobacteria. These ancient builders created layered mounds called stromatolites, stacking thin sheets of mineral and organic matter year after year, century after century. The process was so slow it would have been invisible to any observer, like watching paint dry across millennia. Yet gradually, these living stones grew into towering pillars and sprawling platforms that covered vast stretches of the seafloor. What makes this even more remarkable is that these humble microbes were quietly performing one of the most important jobs in Earth's history. They were learning to harvest sunlight, releasing oxygen as a byproduct of their daily work. Drop by drop, breath by breath, they were transforming the planet's atmosphere, setting the stage for every breathing creature that would ever live. Today, you can still find stromatolites growing in a few special places around the world, like living fossils continuing their ancient craft. They remind us that some of Earth's most profound changes happen not through dramatic catastrophes, but through the gentle persistence of tiny builders working in perfect rhythm with time itself. The early Earth spun much faster than it does today, and nights were wonderfully brief. 4 billion years ago, a single day lasted only about 6 hours. The young planet was like a child, restless and energetic, spinning through space with enthusiasm. The moon, which was much closer then, loomed enormous in the sky, perhaps appearing 3 times larger than it does now. This cosmic dance between Earth and moon was gradually slowing down through a process so gentle it's almost like a lullaby. The moon's gravity tugged at Earth's oceans, creating massive tides that acted like a brake on the planet's rotation. Meanwhile, Earth's gravity was slowly pushing the moon away, sending it on a spiral path outward into space. The effect was so subtle that no living thing could have noticed it happening. Each day grew longer by just microseconds per year. But over millions and billions of years, these tiny changes accumulated. The frantic 6-hour days stretched into 8 hours, then 12, then finally the familiar 24-hour rhythm we know today. This cosmic slowing created something beautiful. As days grew longer, the planet had more time to cool each night and warm each day. Weather patterns became more stable. Seasons became more predictable. Life had more time to adapt to the gentle cycles of light and darkness that would become the heartbeat of all earthly existence. Even now, the moon continues to drift slowly away from us, and our days continue to grow longer. But the change is so gradual, so peaceful, that it's like falling asleep to the rhythm of a clock that ticks just slightly slower each night. Ancient Earth was painted in colors we rarely see today. For nearly 2 billion years, the planet's oceans shimmered with bands of red and orange, like a permanent sunset reflected in every sea. This wasn't the blue world we know, but something that would have looked almost alien to modern eyes. The colors came from iron dissolved in the ancient oceans. In those early times, there was very little oxygen in the atmosphere, so iron could flow freely through the water without rusting. The seas were rich with this dissolved metal, giving them a warm, reddish tint that stretched from horizon to horizon. But then came the great change. As cyanobacteria spread across the planet, pumping oxygen into the atmosphere, something remarkable happened. The oxygen began to react with all that dissolved iron, causing it to rust and fall to the bottom of the oceans like gentle snow. Layer after layer of iron-rich sediment settled on the seafloor, creating some of the most beautiful rock formations on Earth. These banded iron formations, as geologists call them, tell the story of Earth's first great transformation. You can see them today in places like Australia and Minnesota, where ancient seafloors have been lifted up and exposed. They look like geological artwork with alternating stripes of red, black, and silver that record the slow, steady change from an iron-rich world to an oxygen-rich one. The transformation took hundreds of millions of years. Gradually, the rusty oceans cleared, becoming the blue waters that would eventually cradle the first fish, the first whales, and countless generations of ocean life. It was one of the most peaceful revolutions in Earth's history, a change so slow and gentle that it unfolded like a very long meditation on the nature of time itself. The first snow may have covered the entire planet in a blanket of white. Around 700 million years ago, Earth experienced what scientists call snowball Earth events, periods when ice stretched from the poles all the way to the equator. The planet became a giant snowball spinning through space, wrapped in a crystalline shell that sparkled under the distant sun. These weren't brief ice ages, but frozen epochs that lasted millions of years. The ice sheets grew so thick that they reflected most of the sun's warmth back into space, creating a feedback loop that kept the planet locked in its icy embrace. Rivers froze solid, oceans turned to ice several feet thick. Even near the equator, temperatures dropped far below freezing. Yet life persisted in this frozen world. Deep beneath the ice, in the dark waters of the ocean depths, simple organisms continued their quiet existence. Hot springs on the seafloor provided islands of warmth where communities of microbes thrived, waiting patiently for the world to thaw. The end of each snowball Earth period was as gradual as its beginning. Volcanoes continued to pump carbon dioxide into the atmosphere throughout the Ice Age. With no plants or weathering to remove it, this greenhouse gas slowly accumulated over millions of years. Eventually, the atmosphere reached a tipping point where the greenhouse effect became strong enough to begin melting the global ice sheet. The thaw, when it came, was like the planet awakening from a very long winter's sleep. As the ice retreated, it revealed a world scrubbed clean and ready for new possibilities. Many scientists believe these snowball Earth events helped trigger some of the most important evolutionary advances in life's history. as if the planet needed these periods of deep rest to dream up new forms of existence. The earliest forests were made not of trees, but of giant mushrooms. Around 400 million years ago, when life was first venturing onto dry land, the landscape was dominated by towering structures called proto-taxites. These mysterious organisms grew up to 24 feet tall and several feet wide, creating forests of what looked like enormous tree trunks scattered across the continents. But these weren't trees at all. They were fungi, related more closely to the mushrooms in your garden than to any plant. They had no leaves, no branches, no roots in the traditional sense. Instead, they were massive columns of fungal tissue, perhaps feeding on the organic matter left by earlier marine life that had washed up on ancient shores. Imagine walking through one of these primordial forests. The silence would have been profound, broken only by the whisper of wind through these strange pillars. There would have been no bird songs, no rustle of leaves, no buzz of insects. Just the quiet presence of these ancient giants standing like sentinels in a world still learning how to be green. These fungal forests may have played a crucial role in preparing the land for the plants that would eventually take over. As they grew and died, they helped create the first soils, breaking down rock and organic matter into the rich earth that would nourish future vegetation. They were Earth's patient gardeners, spending millions of years preparing the ground for the forests we know today. Eventually, as plants developed better ways to live on land, the great fungi forests faded away. But their legacy remains in every handful of soil, every root system, every partnership between plants and the fungal networks that still help them thrive. They remind us that sometimes the most important work happens quietly in ways we might not immediately recognize as beautiful or important. Continental drift was like a very slow dance that lasted hundreds of millions of years. The continents we see on maps today have wandered across the planet's surface, spinning and sliding and embracing each other in combinations that would have made the ancient world unrecognizable to modern eyes. Around 300 million years ago, all the major land masses came together to form a single supercontinent called Pangaea. It was a massive landmass surrounded by one enormous ocean, creating weather patterns and landscapes unlike anything we see today. The interior of Pangaea was incredibly dry, forming vast deserts that stretched for thousands of miles without relief. But Pangaea wasn't permanent. Like everything in Earth's long story, it was just a temporary arrangement. The same forces that had brought the continents together began to pull them apart again. Slowly, almost imperceptibly, cracks appeared in the supercontinent. New oceans began to form as the land masses drifted away from each other. This continental breakup happened so gradually that if you could have watched it in real time, it would have been like observing the hour hand of a clock. The Atlantic Ocean opened at a rate of just a few centimeters per year, about as fast as your fingernails grow. But given enough time, this gentle spreading created an ocean thousands of miles wide. The dance continues today. The continents are still moving, still drifting across the planet's surface at their leisurely pace. In millions of years from now, the world map will look completely different again. Australia is sliding northward toward Asia. Africa is slowly rotating as it pushes into Europe. The Atlantic continues to widen while the Pacific gradually shrinks. This continental drift creates a soothing sense of impermanence. Nothing is fixed, nothing is final. Even the seemingly solid ground beneath our feet is part of an ongoing journey, a planetary meditation on movement and change that unfolds over timescales so vast they make human concerns feel wonderfully small and temporary. The ancient atmosphere was thick and dreamy, like living inside a greenhouse. Early in Earth's history, the air pressure was much higher than it is today, and the atmosphere was rich with carbon dioxide and water vapor. This created a world wrapped in a warm, humid embrace that would have felt like stepping into a tropical conservatory. Under these dense skies, weather patterns moved slowly and gently. The thick atmosphere held heat like a blanket, keeping temperatures stable across the planet. There were no polar ice caps, no frozen regions. Even the highest latitudes enjoyed subtropical warmth, with palm trees and ferns growing in places that are now covered by ice and snow. Rain fell in gentle, persistent showers that could last for days or weeks. The water cycle moved at a different pace then, more like a slow breathing rhythm than the quick gasps of modern weather. Clouds formed thick, low layers that filtered the sunlight into a soft, diffused glow. It would have been a world of perpetual golden hour where harsh shadows were rare and everything was bathed in gentle, even light. This thick atmosphere also meant that sounds traveled differently. Voices would have carried farther, and the air would have felt substantial, almost liquid in its density. Flying creatures, when they eventually evolved, found it easier to stay aloft in this dense air, gliding effortlessly through skies that supported them like invisible water. As plants spread across the land and began removing carbon dioxide from the atmosphere, this dreamy world gradually faded. The air became thinner and clearer. Ice caps formed at the poles. Weather became more dramatic and changeable. But for hundreds of millions of years, Earth was wrapped in this gentle, atmospheric embrace, a planet-sized sanctuary where life could unfold at its own peaceful pace. Ancient rain was different too, falling from skies that had never known pollution or jet trails. For billions of years, precipitation was pure distilled water, carrying only the natural minerals it picked up from rocks and soil. Each raindrop was crystal clear, tasting of nothing but the sky itself. These ancient rains carved the first river systems, creating networks of waterways that wound across the continents like the veins of some enormous sleeping creature. Without vegetation to hold the soil in place, early rivers meandered freely, changing course whenever they encountered the slightest resistance. They created vast floodplains and deltas, spreading nutrient-rich sediment across the landscape in preparation for the life that would eventually call these places home. The sound of ancient rain would have echoed differently across the empty continents. With no forests to muffle the drops, no buildings to create complex rhythms of runoff, the percussion of precipitation would have been pure and simple. Just the gentle drumming of water on stone, creating natural music that played for millions of years before the first ear evolved to hear it. The first mountains rose from the sea like sleeping giants awakening from dreams. Around 4 billion years ago, the earliest mountain ranges began to emerge as the young Earth's crust started to wrinkle and fold. These weren't the sharp, dramatic peaks we might imagine, but gentle swells in the landscape that rose slowly from the primordial oceans like the backs of enormous whales surfacing for air. These ancient highlands were born through a process so gradual it defied perception. As tectonic plates bumped into each other with the gentleness of clouds colliding, the rock layers compressed and buckled, creating folds that took millions of years to reach their full height. The mountains grew at the pace of fingernails, rising perhaps a few millimeters each century, their birth measured not in human lifetimes, but in geological epochs. What made these early mountains particularly peaceful was their softness. Without the hardy plants we know today to hold soil in place, the mountains eroded almost as quickly as they rose. Wind and rain carved them into rounded, gentle forms that rolled across the horizon like frozen waves. They were mountains that knew how to surrender, allowing themselves to be slowly worn down even as deep forces continued to push them skyward. The ancient peaks stood in magnificent solitude, surrounded by vast, empty spaces where no footstep had ever fallen. No snow crowned their summits because the early atmosphere was too warm. No trees dotted their slopes because forests had not yet been invented. They were pure geology, raw earth reaching toward alien skies, patient monuments to the planet's slow dance with time. Many of these first mountain ranges have long since been worn completely away, their substance scattered grain by grain across ancient seas. But their memory lives on in the rocks they left behind, in the mineral veins they created, and in the gentle rolling landscapes where their roots still sleep beneath younger stones. The early oceans were warm as bathwater and twice as salty. In those distant times, the sea's average temperatures that would feel like a comfortable hot tub, hovering around 130 to 140 degrees Fahrenheit. The water was so warm that it could barely hold dissolved gases, creating an environment unlike any ocean we know today. This warmth came from several sources working together in harmony. The young planet still radiated heat from its violent formation, like a stone slowly cooling after being pulled from a fire. Volcanic activity was much more intense then, with underwater vents constantly adding their thermal energy to the oceanic mix. Most importantly, the atmosphere was thick with greenhouse gases that wrapped the planet in a thermal blanket, keeping the oceans perpetually warm. The extra saltiness came from the constant erosion of the early continents. With no vegetation to slow the process, rocks dissolved quickly in the warm, acidic rains of the time. Rivers carried this dissolved mineral wealth to the oceans, where it accumulated over millions of years. The seas became rich broths of sodium, magnesium, and countless other elements that would eventually become the building blocks of life. Swimming in these ancient oceans would have felt like floating in a mineral spring. The water would have been thick and substantial, almost syrupy compared to modern seawater. Waves moved more slowly through the dense, warm liquid, creating a rhythm that was more like breathing than the quick chop of contemporary seas. As the planet gradually cooled and life began to change the atmospheric composition, these bathwater oceans slowly transformed into something more familiar. But for hundreds of millions of years, Earth was wrapped in seas that felt like a planetary spa, warm and mineral-rich waters that cradled the first stirrings of life with infinite gentleness. Volcanic activity in ancient times was both more frequent and more peaceful than we might expect. Rather than the violent explosions we often associate with volcanoes today, early volcanic activity was characterized by gentle, persistent outpourings of lava that flowed like thick honey across the landscape. These weren't catastrophic events, but slow, meditative processes that could continue for thousands of years without pause. The lava flows of ancient Earth created some of the most soothing geological formations on the planet. As the molten rock cooled, it formed smooth, rolling hills and vast plateaus that stretched for hundreds of miles. The cooling process itself was remarkably peaceful, with the rock contracting slowly and evenly, sometimes creating natural columns and geometric patterns that look almost like ancient architecture. These early volcanoes also played a crucial role in creating the planet's first stable atmosphere. They released water vapor that would eventually condense into the first permanent oceans, along with carbon dioxide that helped regulate the planet's temperature. It was a slow, steady breathing of the Earth itself, exhaling the gases that would make life possible. Many of these ancient lava flows are still visible today, though they've been weathered and shaped by billions of years of gentle erosion. In places like the Canadian Shield and parts of Australia, you can still see the smooth, rounded forms of these primordial volcanic landscapes, worn down to their essential shapes like stones polished by an infinitely patient river. The rhythm of ancient volcanism was like a slow heartbeat of the planet, pumping vital materials to the surface and helping to create the stable, life-friendly environment that would eventually emerge. Each flow was a small gift to the future, adding another layer to the foundation upon which all subsequent life would build. The first ice appeared not as violent glaciers, but as delicate frost crystals forming in the planet's highest places. Around 3 billion years ago, as the atmosphere began to cool and stabilize, water vapor started to condense into solid form for the first time in Earth's history. These weren't the massive ice sheets we associate with ice ages, but gentle accumulations of frozen water that sparkled like scattered diamonds across the landscape. The formation of ice marked a profound shift in the planet's character. For the first time, water existed in all three of its forms simultaneously, creating a more dynamic and interesting world. The ice reflected sunlight back into space, helping to cool the planet gradually and creating feedback loops that would eventually stabilize Earth's climate. These early ice formations were incredibly pure, formed from atmospheric water that had never touched the ground. They accumulated slowly in the shadows of the first mountains, in the depths of the earliest valleys, creating pockets of crystalline beauty that caught and scattered the ancient sunlight into rainbow fragments. The ice also began to shape the landscape in new ways. As it formed and melted with the changing seasons, it carved subtle channels in the rock, polished stone surfaces to mirror smoothness, and transported tiny fragments of mineral from high places to low. It was the beginning of a new kind of erosion, gentler and more artistic than the harsh chemical weathering that had dominated the early Earth. Watching ice form for the first time would have been like witnessing the planet learning a new skill, discovering another way to sculpt itself into ever more beautiful and complex forms. Each crystal was a small miracle, a perfect geometric structure created by the simple process of water slowing down and finding its most peaceful arrangement. Ancient tides were dramatic performances that played out over hours instead of the familiar twice-daily rhythm we know today. With the moon much closer to Earth, gravitational forces were far stronger, creating tidal ranges that could stretch for hundreds of miles inland. But these massive tides moved slowly, like gentle tsunamis that took their time crossing the continents. The early Earth's shorter days meant that tidal cycles were completely different from what we experience now. Instead of the familiar high and low tide pattern, there would have been complex, overlapping rhythms as the close moon orbited quickly around the rapidly spinning planet. It was like a cosmic dance with intricate steps that repeated every few hours in slightly different variations. These ancient tides carved temporary seas that appeared and disappeared with dreamlike regularity. Vast areas of the early continents would flood slowly as the tide came in, creating shallow, warm lagoons that stretched to the horizon. Then, just as gradually, the water would retreat, leaving behind salt flats and temporary pools that sparkled under the alien sky. The sound of ancient tides would have been unlike anything we hear today. Without beaches to break against, the water simply rose and fell across flat expanses of rock and sediment, creating a whisper of movement that could be heard for miles. It was the breathing of the planet made audible, a rhythm so vast and slow that it would have felt like being inside the chest of some enormous sleeping creature. Life forms that existed during these times had to adapt to this constant rhythm of flooding and exposure. They learned to live in both aquatic and terrestrial conditions, switching between water breathing and air breathing as the tides demanded. These tidal zones became some of the most important laboratories for evolution, places where life experimented with new ways of existing between two worlds. The ancient carbon cycle moved like a meditation, processing elements through the Earth system with infinite patience. Unlike today's rapid carbon exchanges driven by forests and fossil fuel burning, the early carbon cycle was a slow, steady circulation that took millions of years to complete each loop. Carbon would spend eons locked in rocks, gradually weather out into the atmosphere, dissolve into the oceans, and eventually settle back into sediment with the rhythm of a planetary breath held for geological ages. Volcanic activity provided the primary source of carbon dioxide, releasing it steadily into the atmosphere through countless vents and fissures. This wasn't the dramatic outgassing of major eruptions, but a constant, gentle exhalation that maintained atmospheric levels through deep time. The carbon would then dissolve into the warm, ancient oceans, where it combined with minerals to form the first limestone and other carbonate rocks. The process created a natural thermostat for the planet. When volcanic activity increased, more carbon dioxide entered the atmosphere, warming the planet and increasing weathering rates. The enhanced weathering would then remove more carbon from the atmosphere, cooling things down again. It was a feedback system so gentle and gradual that it maintained relatively stable conditions for hundreds of millions of years. This ancient carbon cycle also created some of Earth's most beautiful rock formations. As carbon-rich waters evaporated or cooled, they left behind delicate mineral structures, layered deposits, and crystalline formations that still catch the light today. Each layer tells part of the story of this slow, peaceful circulation, a record written in stone of the planet's patient work to maintain balance. Without life to complicate the process, the early carbon cycle had a purity and simplicity that's almost musical. It was chemistry in its most elemental form, atoms dancing slowly through the Earth system in patterns that repeated across millions of years like a very long, very quiet song. The first magnetic field flickered to life like a gentle aurora wrapping around the entire planet. Deep within Earth's molten core, currents of liquid iron began to swirl in patterns that would create one of the most protective and invisible gifts the planet would ever give itself. This wasn't a sudden switch being flipped, but a gradual awakening that took millions of years to fully establish. The birth of Earth's magnetic field was like watching a cosmic lighthouse slowly learn to shine. As the planet's core cooled and organized itself into layers, the flowing metal created electrical currents that generated magnetic forces. These forces reached outward through the rock and into space, creating an invisible shield that would deflect harmful radiation from the sun and cosmos beyond. In those early times, the magnetic field was unstable, flickering on and off like a candle in a gentle breeze. Sometimes it would weaken almost to nothing, leaving the atmosphere temporarily vulnerable to solar winds. Other times it would strengthen and shift, with magnetic north wandering across the globe like a compass needle trying to find its true direction. What makes this magnetic birth even more remarkable is how it transformed the planet's relationship with space. Before the magnetic field existed, solar radiation could strip away atmospheric gases, slowly eroding the air that life would eventually need to breathe. But once the magnetic shield was in place, Earth could hold on to its atmosphere more securely, creating a stable envelope of air that would persist for billions of years. The ancient magnetic field also painted the sky with colors that no human eye has ever seen. Aurora displays would have been far more dramatic and frequent, cascading across the heavens in sheets of green, blue, and red light as charged particles from space danced along the magnetic field lines. These light shows played out over empty continents for millions of years, a celestial theater performing for an audience of stones and water. Ancient caves formed like slow-growing dreams deep within the Earth's crust. As slightly acidic groundwater seeped through limestone and other soluble rocks, it began the patient work of dissolution that would create some of the planet's most mysterious and beautiful underground spaces. This wasn't violent erosion, but a gentle chemical conversation between water and stone that could continue for millions of years. The process began with tiny cracks and fissures in the bedrock. Rainwater, enriched with carbon dioxide from the atmosphere, would find these microscopic pathways and begin its slow journey downward. Drop by drop, the slightly acidic water would dissolve minute quantities of rock, gradually widening the cracks into channels, and the channels into passages. Over vast stretches of time, these underground waterways carved out chambers that stretched for miles beneath the surface. The caves grew organically, following the natural weaknesses in the rock, creating networks of tunnels and galleries that spiral through the Earth's crust like the chambers of an enormous heart. Each passage was unique, shaped by the particular chemistry of its water and the specific minerals it encountered. In the darkness of these ancient caves, water continued its artistic work, creating formations of breathtaking delicacy. Mineral-rich droplets falling from cave ceilings built stalactites grain by grain, while corresponding stalagmites grew upward from the floors to meet them. The process was so slow that a single formation might take hundreds of thousands of years to grow just a few inches. These underground cathedrals became refuges for early life forms, providing stable temperatures and protection from the harsh conditions that sometimes swept across the surface. In the absolute darkness of the deepest chambers, unique ecosystems evolved, learning to thrive without sunlight in environments that remained unchanged for millions of years. The formation of ancient river deltas was like watching the earth learn to write in cursive. As the first major rivers reached the early oceans, they slowed and spread their sediment load in graceful, branching patterns that resembled enormous fans laid out across the seafloor. These deltas were places where land and water collaborated to create some of the most fertile and dynamic landscapes on the planet. Unlike modern deltas, which are often constrained by existing geography, the ancient river mouths had vast empty spaces to work with. They could spread their sediments across hundreds of square miles, creating networks of channels that shifted and changed with each flood season. The rivers wrote their stories in sand and silt, constantly revising and rewriting the text of the landscape. The process was incredibly peaceful to observe across geological time. Sediment would settle out of the slowing water like snow falling through honey, building up layer upon layer in patterns that reflected the river's changing moods. During flood seasons, coarser materials would be deposited farther from shore. In calmer times, fine clays and silts would drift down to create smooth, even surfaces. These ancient deltas became some of Earth's most important archives, preserving detailed records of climate, weather, and geological activity in their layered sediments. Each stripe of clay or sand represented a season, a year, or sometimes an entire century of the river's history. Reading these deposits today is like flipping through the pages of Earth's autobiography, written in the language of flowing water and settling particles. The deltas also created unique environments where fresh water mixed with salt water, generating chemical conditions that would prove crucial for early life. These brackish zones became natural laboratories where organisms could experiment with different ways of processing salt, managing water balance, and adapting to changing conditions. The first atmospheric layers separated like cream rising in cosmic milk. As the early atmosphere evolved and thickened, it began to organize itself into distinct zones, each with its own temperature, pressure, and chemical characteristics. This stratification happened so gradually that it was like watching the sky learn to breathe in different rhythms at different altitudes. The lowest layer, closest to the Earth's surface, was thick and warm, heavy with water vapor and volcanic gases. This was where weather happened, though the weather patterns of ancient Earth were unlike anything we experience today. Storms moved slowly through the dense air, and temperature changes were gradual and gentle, moderated by the atmosphere's high heat capacity. Above this surface layer, the air gradually thinned and cooled, creating what would eventually become the stratosphere and upper atmospheric zones. Without the complex chemistry of modern atmospheric layers, these early zones were simpler but no less important. They helped regulate the planet's temperature and protected the surface from harmful radiation, even in their primitive form. The separation of atmospheric layers also created the first crude weather systems. Convection currents began to develop as warm air rose from the surface and cooled air descended from higher altitudes. These currents were much slower and gentler than modern weather patterns, creating a planetary circulation system that moved like a vast, slow heartbeat. What made these early atmospheric layers particularly fascinating was their purity. Without pollution, without complex organic compounds, without the myriad chemicals that characterize modern air, each layer was composed of just a few simple gases in various concentrations. It was atmosphere in its most essential form, performing its basic functions of insulation and protection with elegant simplicity. Ancient earthquakes moved like giants turning over in their sleep. The tectonic activity of early Earth was characterized not by the sharp, sudden jolts we associate with modern earthquakes, but by slow, gradual adjustments as the planet's crust settled into its new configurations. These weren't catastrophic events, but gentle rearrangements that unfolded over years or decades. The early crust was thinner and more flexible than today's rigid tectonic plates. When stresses built up along fault lines, they were often released gradually through long periods of slow slip rather than sudden ruptures. The ground might shift continuously for months, moving at rates so slow they would barely be perceptible from day to day. These gentle earthquakes created landscapes of remarkable smoothness and flow. Without the sharp scarps and dramatic offsets of modern seismic activity, the ancient terrain rolled and undulated like fabric being slowly stretched and folded. Fault lines appeared as gentle valleys and ridges rather than dramatic breaks in the landscape. The sounds of ancient earthquakes would have been quite different too. Instead of the sharp crack and rumble of modern seismic events, early crustal movements would have produced deep, sustained vibrations that could be felt more than heard. These were the growing pains of a planet learning to manage its internal stresses with patience and gradation. Even when more dramatic adjustments were necessary, they often happened through slow uplift or subsidence that took thousands of years to complete. Mountains rose like very slow waves, valleys sank like depressions forming in soft clay, and the entire process had a dreamlike quality that made sudden change seem almost impossible. The development of ancient soil was like watching the earth learn to garden itself. Before plants existed to contribute organic matter, soil formation was a purely mineral process, driven by the patient weathering of rock and the gradual accumulation of fine particles carried by wind and water. This proto-soil was simple but essential, providing the foundation for all future terrestrial life. The process began with the mechanical breakdown of rock through freeze-thaw cycles, thermal expansion, and the grinding action of wind-blown particles. Large boulders slowly cracked and crumbled, becoming smaller rocks, then pebbles, then sand, then finally the fine particles that could support plant roots millions of years in the future. Chemical weathering also played its part, as slightly acidic rainwater slowly dissolved certain minerals while leaving others behind. This process concentrated some elements while dispersing others, creating the first crude chemical gradients that would eventually become soil horizons. Iron oxidized to create the first rusty colors in the landscape, while other minerals formed clays that could hold water and nutrients. The early soils were thin and patchy, accumulating in depressions and sheltered areas where wind and water couldn't immediately carry them away. They had a raw, mineral taste to them, lacking the rich organic complexity that earthworms and fallen leaves would eventually provide. But they were the first step toward creating the medium in which terrestrial life could take root. These ancient soils also preserve some of Earth's earliest chemical signatures, creating time capsules that geologists can still study today. In their simple mineral compositions, we can read the story of ancient climates, atmospheric conditions, and the slow transformation of raw rock into the nurturing earth that would eventually support forests, grasslands, and all the complex ecosystems of the modern world. The ancient phosphorus cycle moved like nutrients flowing through a very slow bloodstream. Phosphorus, essential for all life but locked away in mineral form, began its billion-year journey from rocks to oceans to sediments, and back again through processes so gradual they seemed almost motionless. This wasn't the rapid cycling we see in modern ecosystems, but a planetary-scale circulation that took geological ages to complete each round. Weathering gradually released phosphorus from ancient rocks, grain by grain, ion by ion. The process was incredibly slow because phosphorus minerals are particularly resistant to dissolution. It might take millions of years for a single boulder to contribute its phosphorus load to the soil and groundwater, making this one of the most patient nutrient cycles on Earth. Once freed from the rocks, dissolved phosphorus would travel through groundwater systems and eventually reach the ancient oceans. There, it became available to early life forms, though in concentrations far lower than what we see today. The scarcity of readily available phosphorus may have been one of the factors that kept early life relatively simple and slow growing. The return journey was equally gradual. Marine organisms would incorporate phosphorus into their tissues and shells, and when they died, this phosphorus would settle to the seafloor as part of the accumulating sediments. Over millions of years, these sediments would be compressed into rock, eventually uplifted and weathered once again to begin the cycle anew. This ancient phosphorus cycle created a natural brake on biological productivity, ensuring that early ecosystems developed slowly and sustainably. It was a planetary wisdom that prevented any single organism or process from depleting essential resources too quickly, maintaining the delicate balance that allowed life to persist and evolve over billions of years. Ancient crystals grew in perfect silence deep within the Earth's crust, where pressure and temperature created conditions ideal for the slow assembly of geometric perfection. These weren't the small crystals we might find in a geode today, but massive formations that grew grain by grain over millions of years, creating underground cathedrals of pure mineral architecture. The process required incredible patience. Hot, mineral-rich fluids would seep through cracks in the bedrock, depositing tiny amounts of dissolved material with each pass. Atom by atom, these deposits would organize themselves according to the rigid mathematical laws that govern crystal structure, building up perfect geometric forms that could grow to enormous sizes given enough time. Some of these ancient crystal chambers were vast, with individual crystals reaching sizes that dwarf anything in the modern world. Imagine caverns filled with quartz pillars the size of tree trunks, or caves lined with perfectly formed geometric shapes that caught and reflected light in patterns of stunning complexity. These were natural art galleries that existed in complete darkness, their beauty witnessed only by the earth itself. The formation of these giant crystals required not just time, but incredibly stable conditions. The temperature and pressure had to remain constant for millions of years. The chemical composition of the mineralizing fluids had to stay consistent, and the growing crystals had to be undisturbed by earthquakes or other geological activity. It was like maintaining perfect conditions for a very long, very delicate experiment. Many of these ancient crystal formations have been destroyed by subsequent geological activity, but some persist in the deepest, most stable parts of the Earth's crust. Occasionally, mining or natural erosion will expose these underground treasures, revealing crystal formations so large and perfect that they seem almost artificial, monuments to the Earth's ability to create beauty through pure patience and mathematical precision. The ancient aurora was a constant companion to early Earth, painting the skies with ethereal light that danced across continents where no eyes had yet evolved to witness the display. Unlike the occasional northern lights we see today, the aurora of ancient Earth was persistent and dramatic, fed by a younger, more active sun and guided by a magnetic field that was still learning to organize itself. These early light shows were far more extensive than modern aurora, reaching much farther from the magnetic poles and appearing in colors that reflected the different atmospheric composition of ancient Earth. The displays might have shimmered with hues we rarely see today, as solar particles interacted with gases that are no longer present in our atmosphere in significant quantities. The aurora moved slowly across the ancient skies, undulating like cosmic curtains in a celestial breeze. Without light pollution or atmospheric haze to dim their brilliance, these displays would have been visible even during the day, adding an otherworldly quality to the already alien landscape of early Earth. The light would have reflected off the surfaces of ancient seas and early ice formations, creating a world that sparkled and glowed with natural electricity. The patterns of ancient aurora were also different because Earth's magnetic field was less stable and organized than it is today. Instead of the relatively predictable oval patterns we see now, early aurora might have appeared as spirals, bands, or even complete rings of light that encircled the planet. These were the visible signatures of a magnetic field learning to channel and direct the stream of charged particles flowing from the young sun. For hundreds of millions of years, this celestial light show played out over empty continents, creating one of the most beautiful phenomena that no living creature would witness for eons to come. It was nature's first art form painted with light and magnetism on the vast canvas of the sky, a daily reminder of the invisible forces that protected and shaped the developing planet. The slow formation of natural bridges and arches began as water found the path of least resistance through ancient rock formations. These weren't carved by violent floods or dramatic geological events, but by the patient persistence of slightly acidic water following microscopic weaknesses in stone, gradually enlarging them over millions of years until they became windows and doorways in the landscape. The process started with tiny cracks or differences in rock density. Water would seep into these imperfections, freezing and thawing with seasonal changes, slowly widening the gaps. Chemical weathering would gradually dissolve certain minerals while leaving others intact, creating hollow spaces within seemingly solid rock faces. Over vast periods of time, these hidden cavities would grow larger and eventually break through to the other side, creating the first natural tunnels and bridges. The breakthrough moment, when water finally carved a complete passage through the rock, might take millions of years to achieve. But once accomplished, it would create some of the most graceful and elegant features in the ancient landscape. These early natural bridges were often much larger and more numerous than what we see today because the rock formations were less weathered and more uniform in composition. Entire regions might have been perforated with arches and bridges, creating landscapes that looked almost like natural cathedrals, with stone pillars supporting vast overhanging roofs. The formation of these features also created unique acoustic environments. Sound would echo and resonate through the stone corridors in ways that wouldn't be duplicated until much later in Earth's history. The wind blowing through natural arches would create deep, organ-like tones that played across empty continents for millions of years before the first ear evolved to appreciate their haunting melodies. Ancient hot springs bubbled up from deep within the earth like warm breath from the planet's sleeping core. These thermal features were far more common and dramatic in early Earth history when the planet's interior was hotter and volcanic activity was more widespread. They created oases of warmth and mineral-rich water that would become some of the most important cradles for early life. The springs formed where groundwater came into contact with hot rocks deep underground, heating to temperatures that would have made the surface water feel like natural hot baths. As this heated water rose back to the surface, it carried with it a rich soup of dissolved minerals, creating pools and streams that sparkled with deposits of sulfur, iron, silica, and countless other elements. The areas around ancient hot springs were transformed into landscapes of remarkable beauty and strangeness. Mineral deposits would build up over time, creating terraced pools, colorful mounds, and delicate formations that looked almost like abstract sculpture. The constant flow of warm water kept these areas green and lush, even when the surrounding landscape was harsh and barren. These thermal environments also created some of the most stable and nurturing conditions on early Earth. While surface temperatures might fluctuate dramatically with changing seasons and climate, the hot springs maintained constant temperatures year-round. This thermal stability made them ideal laboratories for the chemical reactions that would eventually lead to life. The sound of ancient hot springs would have been uniquely soothing, a gentle bubbling and steaming that provided a constant background melody in otherwise silent landscapes. The warm water would have created its own weather patterns as well, generating localized humidity and cloud formation that created microclimates around each thermal feature. Many of these ancient hot spring systems have been preserved in the geological record, their mineral deposits creating colorful layers in rock formations that still tell the story of these warm oases. They remind us that even in Earth's earliest and harshest periods, the planet was already creating spaces of comfort and nurture that would eventually welcome life. The ancient glaciers moved like frozen rivers of time, flowing so slowly that their motion was measured not in miles per hour, but in inches per century. These weren't the dramatic ice sheets we might imagine from modern polar regions, but gentle, persistent flows of frozen water that carved the landscape with the patience of a master sculptor working on a lifetime project. During Earth's early cold periods, ice accumulated in high places and began its leisurely journey downward, following the pull of gravity at a pace that made continental drift seem hurried by comparison. The ice moved like thick honey, deforming and flowing around obstacles with liquid grace despite its solid state. A single glacier might take 1,000,000 years to travel from its birthplace in ancient mountains to its eventual melting point near warmer seas. As these slow-motion rivers of ice moved across the landscape, they performed some of the most delicate geological surgery imaginable. They plucked individual rocks from cliff sides, carried boulders for hundreds of miles, and polished stone surfaces to mirror smoothness. The scratches they left behind, called striations, created patterns in the rock that looked almost like ancient writing, recording the direction and speed of ice that had passed eons ago. The ancient glaciers also created some of Earth's most peaceful sounds. The slow creaking and groaning of moving ice produced deep, resonant tones that could travel for miles through the clear, cold air. Occasionally, the ice would crack and adjust with sounds like distant thunder. But most of the time, the glacial landscape was profoundly quiet, broken only by the gentle tinkling of meltwater finding its way through channels in the ice. When these ancient glaciers finally retreated, they left behind landscapes of extraordinary beauty. Valleys carved into perfect U-shapes, lakes nestled in basins scooped out by the ice, and scattered boulders that seemed to have been placed deliberately by some enormous artistic hand. The land they revealed was scrubbed clean and ready for new beginnings, polished and prepared for whatever life forms would eventually call these places home. The formation of ancient salt deposits was like watching the earth preserve its tears for future generations. As shallow seas evaporated under the warm skies of early Earth, they left behind layers of crystalline salt that accumulated grain by grain into deposits hundreds of feet thick. This wasn't a violent process, but a quiet concentration of minerals that took place over millions of years, as water slowly gave up its dissolved treasures to the patient Earth. The process began when inland seas became isolated from the main oceans, trapped in basins where evaporation exceeded the inflow of fresh water. As the water level dropped, the concentration of dissolved minerals increased until the water became so salty that crystals began to form and settle to the bottom. Each crystal was perfect in its geometric form, a tiny monument to the mathematical precision that governs the natural world. Different minerals precipitated out at different stages of the evaporation process, creating layered deposits that told the story of each ancient sea's final days. First came the least soluble salts, followed by more soluble compounds as the brine became increasingly concentrated. The result was stratified deposits with distinct layers of white, pink, and red crystals that created natural artwork in the geological record. These ancient salt beds became time capsules, preserving not just minerals but also tiny bubbles of the ancient seawater itself. Trapped within the crystal structures were samples of Earth's early oceans, complete with their original chemical composition, and sometimes even microscopic organisms that had been swimming in those waters millions of years ago. The beauty of these salt deposits was often breathtaking. When exposed by later geological activity, they created landscapes of pure white and colored crystals that sparkled under the ancient sun like fields of scattered gems. Some deposits formed natural sculptures as the salt recrystallized over time, creating spires, caves, and formations that rivaled anything carved by human hands. Ancient sand dunes migrated across continents like slow-motion waves frozen in stone. These weren't the small, temporary dunes we might see at a beach, but massive formations that could stretch for hundreds of miles and stand several hundred feet tall. They moved across the landscape at the pace of geological time, shifting and reshaping themselves grain by grain as ancient winds rearranged their substance with infinite patience. The formation of these great dune fields required very specific conditions that existed more commonly in Earth's distant past. Vast areas of exposed sand, created by the weathering of ancient mountains and the retreat of shallow seas, provided the raw material. Persistent wind patterns, uninterrupted by forests or other vegetation, could then organize this sand into the elegant curved forms that characterize mature dune systems. Each grain of sand in these ancient dunes had its own epic journey. A single quartz crystal might have started its life as part of a granite mountain, been liberated by millions of years of weathering, traveled down ancient rivers to prehistoric seas, been deposited on beaches that no longer exist, and finally picked up by wind to join the slow dance of the migrating dunes. The ancient dunes created their own unique environments and weather patterns. The huge sand masses absorbed heat during the day and radiated it back at night, creating temperature differences that generated their own wind systems. These local breezes would constantly reshape the dune's surfaces, creating ripple patterns and slip faces that changed daily while the overall form of the dune moved imperceptibly across the landscape. When these ancient dune fields were eventually buried and compressed into rock, they preserved perfect records of the wind patterns and climate conditions of their time. The cross-bedding patterns visible in sandstone formations today tell the story of these prehistoric sand seas. showing us the direction the dunes moved and the strength of the winds that shaped them millions of years ago. The development of ancient river meanders was like watching cursive writing appear across the landscape as flowing water learned the art of taking the scenic route. Early rivers, unconfined by the vegetation and human alterations that constrain modern waterways, were free to wander across vast floodplains, creating loops and curves that grew more elaborate over time, as the water followed the path of least resistance. The meandering process was driven by the simple physics of flowing water, but the results were anything but simple. As rivers flowed across relatively flat terrain, small irregularities in the landscape would deflect the current slightly to one side or the other. Once deflected, the flowing water would begin to erode the outside bank, while depositing sediment on the inside bank, gradually exaggerating the curve and creating the characteristic horseshoe bends that define meandering rivers. Over thousands of years, these meanders would grow larger and more pronounced, creating rivers that looped back on themselves in patterns so elaborate they seemed almost decorative. Some ancient meanders were so extreme that the river would nearly complete full circles, flowing for miles to cover distances that could have been traversed in a few hundred yards as the crow flies. The ancient meanders also created some of Earth's most fertile and dynamic landscapes. The constant process of erosion and deposition meant that the river was continuously redistributing nutrients and sediments across its floodplain. Oxbow lakes formed when meanders became so extreme that the river cut through the narrow neck of land separating the two ends of a loop, abandoning the curved section to become a crescent-shaped lake. These meandering river systems created natural art on a continental scale, visible from great heights as graceful curves and spirals that decorated the landscape like brushstrokes on an enormous canvas. The patterns they created were so beautiful and consistent that they would later inspire human art and architecture, proving that nature had been practicing elegant design for hundreds of millions of years. The ancient formation of natural amphitheaters occurred as wind and water collaborated to carve bowl-shaped depressions into hillsides and cliff faces. These weren't created by sudden landslides or dramatic geological events, but by the patient work of erosion that followed the natural weaknesses in rock formations, gradually hollowing out spaces that would have provided perfect acoustics if anyone had been there to appreciate them. The process typically began where softer rock layers were sandwiched between harder formations. As weathering attacked the exposed edges of these softer layers, it would gradually excavate them while leaving the harder rocks above and below relatively intact. Over millions of years, this selective erosion would create deep alcoves and curved depressions that resembled giant shells carved into the landscape. Wind played a particularly important role in shaping these natural amphitheaters. The curved walls would channel and focus air currents, creating circulation patterns that enhanced the erosional process. Sand and small particles carried by the wind would act like natural sandpaper, polishing the curved surfaces smooth and gradually enlarging the chambers. These ancient amphitheaters often had remarkable acoustic properties, even though no audience would exist to test them for hundreds of millions of years. The curved walls would focus and reflect sound waves, creating natural echo chambers that could amplify the slightest whisper or the gentle sound of wind moving through the hollow spaces. Some of these formations also became natural rain collectors, concentrating precipitation that fell over wide areas into the curved depressions. This made them oases of moisture in otherwise dry landscapes, creating microenvironments that would later become important refuges for early life forms when they finally appeared on the terrestrial stage. The slow accumulation of ancient peat deposits was like watching the earth create its first libraries, storing organic matter in layers that would preserve the history of early terrestrial life for hundreds of millions of years. These weren't the rapid accumulations we might see in modern swamps, but gradual buildups that occurred over geological timescales as dead plant material slowly accumulated in waterlogged environments where decay was inhibited by lack of oxygen. The formation of ancient peat required very specific conditions that were more common in Earth's distant past. Vast wetland areas created by the flooding of low-lying terrain provided the waterlogged conditions necessary to prevent complete decomposition. The warm, humid climate of many ancient periods meant that plant growth was vigorous, providing abundant organic matter to fuel the peat-forming process. Each layer of peat was like a page in Earth's autobiography, containing perfectly preserved plant material that recorded the climate, atmospheric composition, and ecological conditions of its time. Leaves, stems, spores, and even entire tree trunks could be found in these deposits, freeze-dried by the anaerobic conditions into time capsules that would remain intact for hundreds of millions of years. The ancient peat deposits also trapped and concentrated other materials, including minerals dissolved in the groundwater and atmospheric particles that settled on the wetland surfaces. This created complex chemical archives that preserved not just biological information, but also records of volcanic activity, meteor impacts, and other events that might have affected the ancient environment. Over time, many of these peat deposits would be buried and compressed into coal, transforming the stored solar energy of ancient plants into concentrated fuel that would power civilizations millions of years in the future. The process was so slow and thorough that every piece of coal contains the compressed remains of forests that grew and died long before the first animals walked on land. Ancient karst landscapes developed like underground cities as slightly acidic water slowly dissolved limestone and other soluble rocks, creating vast networks of caves, underground rivers, and surface features that seem to have been designed by some patient architect working on a million-year timeline. These weren't created by dramatic events, but by the gentle persistence of chemical weathering that could turn solid rock into hollow spaces given enough time. The process began with rainwater that had absorbed carbon dioxide from the atmosphere, making it slightly acidic. As this acidic water seeped into cracks and joints in limestone formations, it would slowly dissolve the rock along these pathways, gradually enlarging them into channels and eventually into full-sized cave systems. The dissolution was so gradual that a single cave passage might take millions of years to carve. As the underground drainage systems developed, they began to affect the surface landscape as well. Streams would disappear into sinkholes, flowing underground for miles before emerging as springs in distant locations. The surface above the cave systems would sometimes collapse as the underlying support was dissolved away, creating natural bridges, arches, and circular depressions that dotted the landscape like geological punctuation marks. The ancient karst systems created some of the most complex and beautiful underground environments on Earth. Multi-level cave systems with rooms the size of cathedrals, underground waterfalls cascading through limestone chambers, and crystal formations growing in absolute darkness like mineral gardens tended by invisible hands. These underground landscapes also created unique acoustic environments where the slightest sound could echo for minutes through networks of connected chambers. The constant dripping of water from cave ceilings created natural percussion that played out rhythms measured in geological time, while underground streams added their own liquid melodies to the subterranean symphony. The formation of ancient natural arches was poetry written in stone, as erosion followed the hidden weaknesses in rock formations to create some of the most graceful and improbable structures in the landscape. These weren't carved by human hands, but by the patient collaboration of wind, water, ice, and time working together to remove everything that wasn't essential and leave behind only the pure structural elements needed to span open space. The process typically began with vertical fractures or joints in the rock that provided pathways for water infiltration. Over millions of years, freeze-thaw cycles would gradually widen these cracks while chemical weathering dissolved the more soluble minerals. As the cracks grew larger, they would eventually break through from one side of a rock formation to the other, creating the first crude openings. Once an opening was established, the forces of erosion could work more efficiently. Wind-blown sand would scour the interior surfaces, gradually enlarging and smoothing the aperture. Water flowing through the opening during storms would carry away loose material and continue the sculpting process. Even the daily expansion and contraction of the rock due to temperature changes would contribute to the gradual refinement of the arch's shape. The most remarkable aspect of natural arch formation was how the erosional forces seemed to automatically create structurally sound designs. The rock that remained was invariably arranged in the most efficient possible configuration to support the loads above it, as if the stone itself understood the principles of engineering and architecture. Many ancient arches grew to enormous sizes, spanning distances that would challenge modern bridge builders. Some were so large that entire ecosystems could develop in the shelter they provided, creating protected microclimates that supported life forms that couldn't survive in the exposed landscape beyond. The ancient formation of natural pools was like watching the earth learn to hold water in perfect stone basins, each one carved by the patient persistence of flowing streams that found ways to trap and circulate their own flow. These weren't artificial constructions, but natural sculptures created by the interaction of water chemistry, geology, and time, resulting in formations that seemed almost too perfect to be accidental. The process often began where streams flowed over layers of rock with different hardness characteristics. The flowing water would gradually erode the softer layers while leaving the harder rocks relatively intact, creating natural dams and barriers that could hold back pools of crystal clear water. Over thousands of years, the constant flow would polish these basins to incredible smoothness, while gradually deepening and enlarging them. Mineral-rich water flowing through these ancient pools would often deposit thin layers of dissolved materials around their edges, gradually building up natural rims that help contain the water more effectively. These mineral deposits would create rings of color around each pool, marking the high water levels and creating natural artwork that recorded the pool's history in concentric bands of different minerals. The ancient pools created perfect mirrors that reflected the sky and surrounding landscape with startling clarity. In a world without human-made structures or atmospheric pollution, these reflections would have been incredibly pure, creating the illusion that the landscape extended downward into liquid depths that seemed to hold another inverted world. The sound of water flowing between these ancient pools would have been like natural music, with each basin creating its own tone as water spilled over its rim. The various pools would have been tuned to different notes, creating harmonies that change with the water level and flow rate, composing melodies that played continuously for millions of years in landscapes where no ear existed to appreciate their beauty. These natural pool systems also created some of the most stable aquatic environments on early Earth, providing refuge where water temperature and chemistry remained relatively constant, even as climate conditions changed around them. They became natural laboratories where the chemistry of life could experiment with new combinations and possibilities in controlled, protected settings. The formation of ancient mineral veins was like watching the Earth's circulatory system slowly crystallize into permanent beauty. Deep beneath the surface, hot fluids rich with dissolved metals would find their way through hairline fractures in the bedrock, depositing their precious cargo atom by atom along the walls of these narrow channels. The process was so gradual that a single vein might take millions of years to grow just a few inches wide, but the result was pure geological artistry. These hydrothermal solutions carried within them the concentrated essence of the Earth's interior, dissolved metals and minerals that had been liberated from deep rocks by intense heat and pressure. As the fluids rose toward the surface and began to cool, they could no longer hold all these materials in solution. Like sugar crystallizing out of cooling syrup, the metals would precipitate along the fracture walls in bands of silver, gold, copper, and countless other elements. The ancient veins grew in patterns that reflected the changing chemistry of the fluids that created them. Early deposits might be rich in one metal, while later flows would add layers of different composition, creating striped patterns that recorded the geological history of the region. Some veins developed complex branching patterns as the fluids found multiple pathways through the rock, creating underground networks that resembled the roots of enormous stone trees. The beauty of these ancient mineral veins was often breathtaking when exposed by later erosion. Walls of pure quartz shot through with threads of silver, bands of deep blue azurite alternating with green malachite, or sheets of golden pyrite that caught and reflected light like metallic mirrors. These were nature's own jewelry, created in darkness and revealed only when the patient work of erosion brought them to the surface. Ancient glacial lakes formed like temporary seas of liquid crystal, created when retreating ice sheets left behind natural dams of rock and sediment that could hold back enormous volumes of meltwater. These weren't permanent features, but transitional landscapes that existed for thousands or tens of thousands of years, before eventually draining away, leaving behind only subtle traces of their former grandeur. The formation of these glacial lakes began as the climate warmed and massive ice sheets started their slow retreat toward the poles. As the ice melted, it created torrents of meltwater that had to find new paths to the sea. Sometimes this water would become trapped behind natural barriers created by the glacier's own debris, forming temporary lakes that could cover thousands of square miles and reach depths of several hundred feet. These ancient lakes were incredibly pure, filled with water that had been locked in ice for millennia and was now experiencing liquid form for the first time in ages. The water was so clear that sunlight could penetrate to remarkable depths, creating underwater landscapes of crystalline beauty where every pebble on the bottom was visible from the surface. The shorelines of glacial lakes were unlike anything we see in modern water bodies. Without vegetation to stabilize them, the shores were constantly changing as waves carved new patterns in the unconsolidated sediments left behind by the retreating ice. Beach ridges formed at different levels as the lake's water level fluctuated with seasonal melting and evaporation. When these ancient lakes finally drained, either through the gradual erosion of their natural dams or through sudden catastrophic failures, they left behind some of the flattest and most fertile landscapes on Earth. The fine sediments that had settled in their quiet depths became the foundation, for some of the world's most productive agricultural regions millions of years later. The development of ancient hot desert pavements was like watching the earth create natural tile floors across vast expanses of arid landscape. This wasn't a violent process of wind erosion, but a patient sorting and organizing of surface materials that took place over hundreds of thousands of years as the climate slowly removed everything except the most durable stones. The process began in regions where rainfall was just frequent enough to occasionally wash away fine particles, but too sparse to support vegetation that might hold the soil in place. Over time, the smaller grains of sand and silt would be carried away by infrequent but intense rainstorms, while larger pebbles and cobbles remained behind. Gradually, these remaining stones would settle into place, forming a protective armor over the desert floor. As the pavement developed, it became increasingly efficient at protecting itself. The tightly packed stones shed rainwater quickly, preventing it from penetrating and mobilizing more fine material from below. The dark surface absorbed solar heat during the day and radiated it back at night, creating temperature extremes that helped break down any organic matter that might otherwise take root between the stones. These ancient desert pavements created some of the most stable surfaces on Earth, remaining virtually unchanged for millions of years once they reached maturity. They were natural highways that stretched across continents, providing smooth, hard surfaces that could support the weight of enormous creatures without leaving any trace of their passage. The formation of desert pavement also created unique acoustic environments. The hard, flat surfaces reflected sound waves with remarkable efficiency, allowing even the faintest sounds to travel for miles across the empty landscape. A whisper spoken on one side of an ancient pavement field might echo back from distant mountains with startling clarity. Ancient underground rivers carved their own secret highways through the bedrock, creating hidden networks of flowing water that connected distant regions through pathways that remained invisible from the surface. These subterranean streams were born where surface water found its way into cave systems and continued its journey toward the sea, through passages that had been slowly dissolved from solid rock. The formation of underground rivers required a delicate balance of geological conditions. The rock had to be soluble enough to allow the gradual carving of passages, but stable enough to support the roof of the resulting tunnels. The water table had to be at just the right level to maintain flow without flooding the entire system, and the gradient had to be gentle enough to prevent the destructive scouring that would collapse the delicate passages. These hidden rivers often flowed for hundreds of miles through the Earth's crust, connecting mountain watersheds with distant springs in ways that would have seemed magical if anyone had been there to observe the connections. Water that disappeared into a sinkhole in one region might emerge as a spring in a completely different landscape, having traveled through a network of underground passages that had taken millions of years to develop. The underground rivers created their own unique ecosystems in the perpetual darkness of their rocky channels. Specialized organisms evolved to thrive in these lightless environments, developing senses and survival strategies completely different from their surface-dwelling relatives. These subterranean communities became living time capsules, preserving evolutionary experiments that had no equivalent in the sunlit world above. The sound of ancient underground rivers was hauntingly beautiful, a constant murmur that echoed through stone corridors and resonated in hidden chambers. The music of flowing water was amplified and modified by the cave acoustics, creating natural symphonies that played continuously in the darkness beneath the Earth's surface. The ancient formation of natural stone bridges represented some of Earth's most elegant architectural achievements, created through the precise collaboration of erosion and structural geology to produce spans that seemed to defy gravity. These weren't built by any conscious design, but emerged from the patient work of weathering that removed everything unnecessary while leaving behind only the essential structural elements. The process typically began where streams cut through narrow ridges of resistant rock, gradually carving deeper channels that eventually approached each other from opposite sides of the ridge. Over millions of years, the flowing water would thin the separating wall of rock until it finally broke through, creating a natural tunnel. Continued erosion would then enlarge and refine this opening, gradually transforming it into a graceful arch that spanned the stream below. What made these ancient bridges so remarkable was their structural perfection. The forces of erosion seemed to automatically understand the principles of engineering, removing material in exactly the right places to create stable spans while leaving behind elegant curves that distributed weight with mathematical precision. The resulting bridges often lasted for millions of years, supporting their own weight and withstanding earthquakes, floods, and climate changes that destroyed countless other geological features. Some of these ancient stone bridges grew to enormous proportions, spanning distances that would challenge modern engineers and reaching heights that created natural cathedrals in the landscape. The spaces beneath them became sheltered environments where unique microclimates could develop, protected from the extremes of weather that affected the surrounding terrain. The acoustics beneath these natural bridges were often extraordinary, creating echo chambers that could amplify and sustain sounds for remarkably long periods. The arched stone ceilings acted like natural amplifiers, focusing and reflecting sound waves in patterns that created some of the most perfect natural concert halls on Earth. Ancient tidal pools formed like natural aquariums along prehistoric shorelines, creating protected environments where the chemistry of early life could experiment with new possibilities in shallow basins that were alternately covered and exposed by the rhythmic breathing of ancient seas. These weren't the small rock pools we might find on modern beaches, but extensive systems of interconnected basins that could stretch for miles along favorable coastlines. The formation of these tidal pool systems required very specific geological conditions that were more common in Earth's distant past. Gently sloping, rocky shores made of resistant but fractured stone provided the foundation, while the extreme tidal ranges created by the closer moon ensured that vast areas would be alternately flooded and exposed with each tidal cycle. As these ancient shores were repeatedly covered and uncovered by the tides, the constant cycle of wetting and drying, heating and cooling, gradually carved intricate networks of pools, channels, and barriers into the rocky platforms. Each pool developed its own unique characteristics based on its size, depth, connection to other pools, and exposure to waves and sunlight. The chemistry within these tidal pools was constantly changing as seawater mixed with rainwater, evaporation concentrated minerals, and organic matter accumulated and decomposed. This created natural laboratories where countless chemical experiments could take place simultaneously, each pool developing its own unique cocktail of dissolved materials and environmental conditions. The ancient tidal pools also created some of the most stable temperature environments available on the early Earth. While surface air temperatures might fluctuate dramatically, the thermal mass of the water in the pools helped moderate these extremes, creating refuges where delicate chemical processes could continue uninterrupted. The development of ancient spring systems was like watching the earth learn to create its own fountains, bringing water from deep underground to the surface through natural plumbing systems that had been carved by the patient work of groundwater over millions of years. These springs weren't simple holes in the ground, but complex systems that could deliver water with remarkable consistency and purity. The formation of spring systems began deep underground, where water would infiltrate through porous rocks and sediments, gradually working its way down to the water table. Once there, it would begin its lateral journey through underground aquifers, following the subtle slopes and channels in the bedrock that guided its flow toward eventual emergence at the surface. The points where springs emerged were often marked by unique geological features created by the constant flow of mineral-rich water. Dissolved materials carried up from the depths would precipitate out as the water reached the surface and its chemistry changed, creating colorful deposits, terrace pools, and delicate mineral formations that grew grain by grain over thousands of years. Ancient springs often created oases of biological activity in otherwise harsh landscapes, providing not just water but also stable temperatures and unique chemical conditions that could support specialized communities of organisms. The constant flow of groundwater maintained consistent conditions year-round, creating refuges where life could persist, even during periods of dramatic climate change. The sound of ancient springs was particularly soothing, a constant, gentle bubbling and flowing that provided a peaceful counterpoint to the silence of empty landscapes. This natural music would play continuously for millions of years, creating some of the most persistent and reliable sounds in the ancient world. The formation of ancient natural dams occurred when geological processes created barriers across river valleys, temporarily redirecting the flow of water and creating some of the most spectacular but short-lived lakes in Earth's history. These weren't permanent structures but transitional features that would eventually be overcome by the persistent power of flowing water. Most ancient natural dams were formed by landslides that blocked river valleys, though some were created by lava flows, glacial deposits, or the gradual accumulation of mineral precipitates. The initial damming event might happen relatively quickly in geological terms, but the resulting lake could persist for thousands or even millions of years before the water finally found a way around or through the obstruction. These temporary lakes created some of the most dramatic landscapes in Earth's history, with water levels that could rise hundreds of feet above the original river channel. The flooded valleys became inland seas that reflected ancient skies and supported their own unique ecosystems adapted to the deep, still waters that had replaced flowing streams. The eventual failure of these natural dams often created some of the most spectacular floods in geological history, as millions of years' worth of accumulated water was suddenly released to resume its journey to the sea. These floods would carve new channels, transport enormous boulders for hundreds of miles, and completely reshape the landscape downstream from the failed dam. The sediments that accumulated in these temporary lakes created detailed records of the climate and environment during their existence, preserving layers of information that geologists can still read millions of years later. Each thin layer of sediment represented a season or a year, creating natural archives that recorded everything from volcanic eruptions to climate changes in remarkable detail. Ancient sand seas covered vast areas of the early continents like golden oceans frozen in time. their dune fields stretching from horizon to horizon in landscapes where the only movement was the imperceptibly slow migration of sand grains, carried by persistent winds. These weren't the temporary accumulations we might see near modern beaches, but permanent features that dominated entire regions for millions of years. The formation of these great sand seas required enormous quantities of fine-grained sediment, usually produced by the weathering of ancient mountain ranges or the drying of prehistoric lake beds. The sand grains would be picked up by wind and transported across vast distances, eventually accumulating in areas where wind patterns favored deposition over erosion. Within these sand seas, individual dunes could grow to enormous sizes, some reaching heights of several hundred feet and lengths measured in miles. The dunes moved across the landscape like slow-motion waves, advancing at rates of just a few feet per year as wind constantly rearranged their substance. The lee faces of the largest dunes created slopes so steep that they would periodically collapse in small avalanches, producing some of the few dynamic sounds in otherwise silent landscapes. The internal structure of ancient sand dunes was remarkably complex, with cross-bedded layers that recorded every change in wind direction and strength. When these dunes were eventually buried and turned to stone, they preserved perfect records of ancient wind patterns, creating geological documents that could be read like weather reports from hundreds of millions of years ago. The surfaces of ancient sand seas were constantly changing as wind created ripple patterns, carved channels, and built new dune forms. Yet despite this constant surface motion, the overall pattern of the sand sea could remain stable for millions of years, creating landscapes that were simultaneously dynamic and permanent. The ancient development of cave systems was like watching the earth create its own cathedrals, carving vast chambers and intricate passages through solid rock with the patient persistence of slightly acidic water working along fractures and joints in limestone formations. These weren't violent excavations, but gradual dissolutions that could take millions of years to create spaces large enough to walk through. The process began where surface water, enriched with carbon dioxide from the atmosphere, would seep into cracks in soluble rock formations. The slightly acidic water would slowly dissolve the rock along these pathways, gradually widening them from hairline fractures to channels and eventually to full-sized passages. The rate of dissolution was so slow that it would take thousands of years to enlarge a crack by just a few inches. As the cave systems developed, they created their own internal weather patterns. Air would flow through the passages like underground wind, while water would continue to drip from ceilings and flow along floors, gradually enlarging and refining the spaces. The constant temperature and humidity in these underground environments created ideal conditions for the slow growth of mineral formations. The chambers carved by these ancient processes often reached cathedral-like proportions, with ceilings that soared hundreds of feet overhead and floors that stretched for acres in perpetual darkness. These spaces existed in perfect silence except for the gentle sounds of dripping water and the occasional whisper of air movement through distant passages. The formations that grew within these caves were masterpieces of natural sculpture, created grain by grain as mineral-rich water deposited its dissolved cargo in delicate structures that defied belief. Stalactites and stalagmites grew toward each other across thousands of years, sometimes meeting to form columns that looked like architectural elements designed by some patient underground architect. As we continue our gentle descent through geological time, these ancient wonders remind us that the earth has always been an artist, working with tools of wind and water, heat and pressure, to create beauty on scales both vast and intimate. Each formation, each process, each slow transformation has contributed to the magnificent planet we know today, built layer by layer through the patient accumulation of countless small changes across the immensity of deep time. The ancient formation of natural amphitheaters carved by thermal springs created some of Earth's most acoustically perfect spaces, hollowed out by the gentle but persistent action of heated groundwater that dissolved rock in perfect circular patterns. These weren't violent excavations, but slow sculptures created by mineral-rich water that bubbled up from deep aquifers, carrying within it the chemical power to dissolve limestone and other soluble rocks grain by grain over millions of years. The process began where underground water was heated by contact with hot rocks deep beneath the surface. As this heated water rose toward the surface, it would find weak points in the bedrock, gradually enlarging these pathways through chemical dissolution. The circular flow patterns created by the rising water would carve bowl-shaped depressions with remarkable symmetry, as if the earth itself understood the principles of acoustic design. These thermal springs created natural concert halls with perfect sound reflection, their curved walls focusing and amplifying even the faintest vibrations. The constant temperature maintained by the hot springs meant that air density remained stable, creating acoustic conditions that could sustain echoes for remarkably long periods. Sound waves would bounce between the curved walls in complex patterns, creating harmonies and resonances that turned every whisper into music. The mineral deposits left by these ancient thermal springs painted the amphitheater walls in bands of color that recorded thousands of years of chemical history. Iron oxides created rusty reds, copper compounds formed blues and greens, while calcium carbonate built up in creamy white terraces that stepped down like natural seeding toward the central pool. Ancient fjords were carved like liquid sculptures by glaciers that moved with the patience of mountains, grinding their way through solid rock to create some of the deepest and most dramatic waterways on Earth. These weren't created by sudden geological catastrophes, but by the slow, persistent pressure of ice that could carve channels thousands of feet deep through the hardest granite and basalt. The glaciers that created these ancient fjords were unlike any ice formations we see today. They were massive rivers of frozen water that could be miles wide and thousands of feet thick, carrying within their crystalline mass the accumulated snowfall of entire mountain ranges. As they flowed toward ancient seas, they carved their pathways with the precision of master sculptors working on a continental scale. The carving process was remarkably gentle despite its enormous scale. The glacier would freeze to the bedrock in some areas while sliding over it in others, plucking away loose rock and polishing solid surfaces to mirror smoothness. The ice acted like both chisel and sandpaper, removing material grain by grain while creating the characteristic U-shaped cross-sections that define fjord valleys. When these ancient glaciers finally retreated, they revealed waterways of breathtaking beauty and depth. Some fjords were carved so deeply that their floors lay thousands of feet below sea level, creating underwater canyons that rivaled any surface mountain range. The walls rose vertically from the dark water like natural skyscrapers, their surfaces polished smooth by the ice that had shaped them. The ancient development of limestone caves created underground palaces where water worked as both architect and artist, dissolving passages through solid rock while simultaneously decorating them with formations of crystalline beauty. The process required perfect timing, as the same water that carved the caves also had to deposit its mineral cargo in exactly the right places to create the delicate structures that would adorn these underground chambers. The chemistry of cave formation was elegantly simple, yet infinitely complex in its results. Rainwater, slightly acidic from dissolved carbon dioxide, would seep into limestone formations and begin the slow work of dissolution. But as this water dripped into underground chambers and began to evaporate, it would reverse the process, depositing dissolved limestone in formations that grew with mathematical precision. Each drop of water that fell from an ancient cave ceiling was like a tiny artist, carrying within it the dissolved remains of the rock above and depositing microscopic layers of new mineral growth on the formations below. Over thousands of years, these individual contributions would accumulate into structures of incredible delicacy and beauty. The formations grew according to the laws of physics and chemistry, creating shapes that seemed almost too perfect to be natural. Stalactites hung from ceilings like stone icicles, while stalagmites grew upward from floors like frozen fountains. When these formations eventually met, they created columns that looked like the pillars of underground cathedrals. Ancient natural bridges formed like stone rainbows, arching over valleys and streams, created by the patient work of erosion that followed the hidden weaknesses in rock formations to carve openings that seemed to defy the laws of gravity. These weren't built by any conscious design, but emerged from millions of years of weathering that removed everything unnecessary while leaving behind only the essential structural elements. The formation process was a masterclass in natural engineering, as water and wind worked together to identify and exploit the subtle differences in rock hardness and composition. Softer layers would be preferentially eroded while harder sections remained, gradually creating openings that would be refined over time into graceful arches that could span enormous distances. Some of these ancient bridges grew to incredible proportions, reaching heights that created natural cathedrals in the landscape while spanning distances that would challenge modern engineers. The spaces beneath them became sheltered environments where unique ecosystems could develop, protected from the extremes of weather that affected the surrounding terrain. The structural perfection of these natural bridges was remarkable, as the forces of erosion seemed to automatically understand the principles of load distribution and stress management. The resulting arches often lasted for millions of years, supporting their own weight and withstanding earthquakes, floods, and climate changes that destroyed countless other geological features. Ancient coral atolls formed like living rings in prehistoric seas, built not by the corals we know today, but by some of Earth's earliest reef-building organisms that constructed vast circular platforms in the warm, shallow waters of tropical oceans. These weren't rapid constructions, but patient accumulations that could take millions of years to grow from small colonies into massive structures that could be seen from great distances across the ancient seas. The formation of these early atolls followed patterns that would be repeated throughout Earth's history, beginning with the volcanic islands that provided stable foundations for reef growth. As the early reef builders colonized these underwater slopes, they began the slow work of construction, adding their skeletal remains layer by layer to create massive limestone platforms. The circular shape of these ancient atolls emerged naturally from the growth patterns of their builders, who thrived best in the shallow, well-lit waters around the edges of the volcanic foundations. As the central volcano gradually sank beneath the waves through natural subsidence, The reef builders continued their upward growth, maintaining their position in the optimal depth zone and creating the characteristic ring-shaped formations. These ancient reef systems created some of the most biodiverse environments in the early oceans, providing countless niches and microhabitats where different organisms could specialize and evolve. The complex three-dimensional structure of the reefs offered protection from predators, abundant food sources, and stable conditions that remained relatively unchanged for millions of years. The ancient formation of natural wells occurred where underground water found pathways to the surface through systems of joints and fractures that had been gradually enlarged by the patient work of groundwater dissolution. These weren't artificial excavations, but natural plumbing systems that could deliver fresh water with remarkable consistency and purity from aquifers that lay deep beneath the surface. The development of these natural wells required very specific geological conditions, including permeable rocks that could store and transmit groundwater, impermeable layers that could confine and direct the flow, and structural features that provided pathways for the water to reach the surface. When all these elements came together in the right configuration, they could create springs and wells that would flow continuously for millions of years. The water that emerged from these ancient wells had often traveled for hundreds or thousands of years through underground rock formations, picking up dissolved minerals and achieving a chemical balance that made it particularly pure and stable. The long residence time underground also meant that the temperature remained constant year-round, creating oases of thermal stability in otherwise variable environments. Some of these natural wells created artesian systems where the underground water was under sufficient pressure to flow freely to the surface without any external pumping. These flowing wells created their own microenvironments, supporting vegetation and wildlife in areas that might otherwise be too dry to sustain complex ecosystems. The formation of ancient badlands created landscapes that looked almost like alien worlds, carved by the relentless work of erosion into intricate mazes of canyons, pinnacles, and layered rock formations that revealed the geological history of their regions in stunning detail. These weren't created by violent catastrophes, but by the patient persistence of wind and water, working on sedimentary rocks that varied in their resistance to weathering. The process typically began in areas where horizontal layers of different rock types had been exposed by uplift or the retreat of ancient seas. As erosion attacked these exposed layers, it would preferentially remove the softer materials while leaving the more resistant rocks behind, creating the characteristic stepped and terraced landscapes that define badland topography. The intricate detail of these eroded landscapes was remarkable, with individual rock layers only inches thick being preserved as distinct bands in the canyon walls. Each layer told part of the story of ancient climates, recording everything from seasonal variations to long-term climate changes in the patterns of sediment deposition and mineral formation. The colors in ancient badlands were often spectacular, ranging from deep reds and oranges created by iron oxides to blues and grays formed by different clay minerals. These natural pigments had been locked away in the sediments for millions of years, only to be revealed by the artistic work of erosion that exposed them to sunlight for the first time. Ancient natural harbors formed where coastal erosion carved, protected bays and inlets into shorelines that provided shelter from the open ocean while maintaining connections to the sea. These weren't designed by any conscious plan, but emerged from the natural interaction between waves, currents, and coastal geology to create some of the most perfect natural anchorages on Earth. The formation of these harbors required a delicate balance of erosional and depositional forces, with harder rocks providing headlands that could deflect ocean waves while softer materials were carved away to create the protected waters behind them. The resulting configurations often achieved an almost perfect balance between protection and access that would be difficult to improve upon with human engineering. The sheltered waters within these ancient harbors created unique environments where sediments could settle and accumulate, building up detailed records of the coastal conditions over millions of years. These protected basins became natural archives that preserved everything from volcanic ash layers to the remains of marine organisms in undisturbed sequences. The wave patterns within these natural harbors were complex and beautiful, as ocean swells were filtered and modified by the entrance configurations to create gentler, more regular patterns in the protected waters. These internal wave systems created their own rhythms and frequencies that could persist for hours after the external conditions that generated them had changed. Ancient sand dune systems migrated across continents like slow-motion tsunamis made of countless individual grains, each following the pull of persistent winds that could transport entire landscapes grain by grain across distances measured in hundreds of miles. These massive dune fields represented some of the most dynamic yet stable features in the ancient world, constantly moving yet maintaining their essential character across millions of years. The formation of these great sand seas required not just abundant sand, but also very specific wind patterns that could maintain consistent direction and strength over geological timescales. The dunes themselves became sculptors of the wind, creating their own local weather patterns that helped perpetuate the conditions necessary for their continued existence and migration. Individual dunes within these ancient systems could grow to enormous proportions, with some reaching heights that rivaled modern skyscrapers while stretching for miles across the landscape. The internal structure of these giant dunes was incredibly complex, with cross-bedded layers that recorded every change in wind strength and direction like natural weather stations built from sand. The movement of these dune systems across the landscape was imperceptibly slow from any human perspective, but devastating in its long-term effects. Entire river systems could be buried and diverted, mountain valleys could be filled, and coastal areas could be transformed as the migrating sands encountered and overcame every obstacle in their path. The preservation of these ancient dune systems in the geological record created some of the most beautiful sandstone formations on Earth, with their cross-bedded layers creating natural artwork that revealed the patterns of ancient winds to anyone who knew how to read the stone. The desert winds of hundreds of millions of years ago were still visible in the rock, frozen at the moment of their final breath. As our journey through these ancient landscapes draws toward its gentle close, we find ourselves surrounded by the quiet testimony of deep time itself. Each formation we've encountered, each slow process we've witnessed, represents millions of years of patient work, the earth sculpting itself grain by grain into the foundation of everything we know today. These ancient processes continue still, working at their own unhurried pace beneath our feet and around us in ways too subtle for daily notice. Mountains are still rising with the patience of stone, rivers are still carving their stories into the landscape letter by letter, and the great cycles of rock and water, heat and cold continue their eternal dance just as they have for billions of years. In the gentle rhythm of these geological processes, we find a profound kind of peace. The same forces that carved the ancient fjords are still at work today. The same chemistry that built the first coral atolls is still creating new reefs in warm seas around the world. The same patient erosion that created natural bridges and arches continues to sculpt new wonders from living rock. The timescales are so vast that they make our daily concerns feel wonderfully small and temporary. In the context of geological time, even our longest-lived civilizations are just brief moments, like single heartbeats in the life of a sleeping giant. Yet we are part of this story, made from the same atoms that once lay in ancient seas, built from the same elements that crystallized in primordial caves. There is something deeply comforting in knowing that the earth has been creating beauty for so long, working with such patience and persistence to craft landscapes of incredible complexity and grace. Every pebble on a beach has been shaped by millions of years of gentle tumbling. Every grain of sand has traveled distances that dwarf human journeys. Every rock holds within it the memory of ancient seas, vanished mountains, and skies that knew no human gaze. The ancient earth we've explored tonight was not a harsh or violent place, despite the dramatic processes that shaped it. Instead, it was a world of profound gentleness where change happened slowly enough that every adjustment could be made gradually. Every transformation could unfold with the patience of stone learning to flow like water. Tonight, as these ancient stories settle around you like layers of sediment, finding their final resting place, let yourself be carried by the rhythm that has sustained our planet for billions of years. The same gentle persistence that carved the deepest canyons and built the highest peaks is working still, invisibly shaping tomorrow from the quiet materials of today. These geological lullabies remind us that the most profound changes happen not through force or urgency, but through the patient accumulation of countless small moments. Each grain of sand that settles, each drop of water that flows, each crystal that grows, is participating in a story so vast and unhurried that it makes the concept of time itself feel soft and forgiving. The ancient earth we've visited tonight continues to live beneath your feet, its deep breathing still lifting mountains by millimeters each year, its circulation still carrying nutrients through underground rivers that have flowed in darkness for millions of years. The very ground you rest upon was once the bottom of ancient seas, once molten rock cooling under alien stars, once part of continents that dance slowly across the globe in combinations we can barely imagine. In every breath you take, you're inhaling atoms that once bubbled up from primordial hot springs, that once dissolved in Precambrian oceans, that once sparkled in the aurora light of a younger, more energetic world. Your body is built from the same elements that crystallized in the first mineral veins, that formed the shells of creatures in long-vanished seas, that fell as gentle rain on landscapes where no footprint had ever marked the shore. The peaceful processes we've explored tonight teach us something profound about the nature of lasting change. The forces that seem most gentle, most easily overlooked, are often the ones that create the most enduring beauty. Water doesn't argue with stone, it simply persists, finding its way around every obstacle with liquid patience until even the hardest granite yields to its touch. Wind doesn't force sand to move, it simply offers an invitation that gets accepted grain by grain until entire deserts migrate across continents. Ice doesn't violently attack the mountains, it flows around them and through them with cold persistence, until valleys are carved and peaks are polished to their essential forms. These ancient rhythms are still available to us, still offering their wisdom about how to live in harmony with time rather than fighting against it. In a world that often demands immediate results and constant acceleration, the geological perspective suggests a different approach. What if we could learn to work with the patience of limestone forming at the bottom of ancient seas? What if we could trust in the power of small, consistent actions repeated over long periods? The way countless tiny organisms built reefs that lasted for millions of years? The ancient earth shows us that the most beautiful and enduring creations emerge not from single dramatic events, but from the gentle persistence of natural processes working in perfect harmony with time itself. The Grand Canyon wasn't carved in a day, but through millions of days of water flowing steadily through stone. The most precious minerals weren't formed by violent explosions, but by the patient cooling and crystallization of solutions deep within the Earth's quiet embrace. As you let yourself drift towards sleep, carried by these ancient currents of geological time, remember that you too are part of this ongoing story. Your life, however brief it may seem against the backdrop of deep time, is contributing to the great work of existence in ways both seen and unseen. Every choice you make, every kindness you offer, every moment of beauty you create or appreciate is adding its own thin layer to the sedimentary record of human experience. The same forces that shaped ancient Earth are shaping you still, working not through geological time but through the moments of your daily life. Patience is still carving new landscapes in your understanding. Persistence is still building new strengths in your character. The gentle pressure of time is still revealing the essential beauty that lies beneath the surface concerns and temporary formations of ordinary experience. Let the ancient earth hold you in its timeless embrace, where mountains dream of becoming sand and oceans remember when they were ice. Where every ending is also a beginning, and every formation is temporary but also eternal, contributing its substance to whatever beautiful thing will emerge next from the patient alchemy of time and change. In this space between waking and sleeping, between the immediate present and the vast perspectives of geological time, you can rest in the knowledge that you are held by forces larger and more gentle than anything you might fear. The same earth that has been creating beauty for billions of years continues its work tonight, with you as both witness and participant in the ongoing miracle of existence itself. Sleep well, and let your dreams be filled with the slow music of planets turning and tides breathing and mountains growing grain by grain toward ancient skies that still remember the first light of dawn, breaking over a world that was already billions of years in the making, already perfect in its patient becoming. And so our gentle journey through deep time draws to its quiet close. We've wandered together through billions of years, witnessing the Earth's most patient artistry unfold in formations that took longer to create than our minds can truly grasp. From the first stromatolites building their living towers to the ancient glaciers carving their slow signatures in stone, each process we've explored reminds us that the most profound beauty emerges not from haste, but from the gentle persistence of natural forces working in perfect harmony with time itself. Tonight, as you drift toward sleep, you carry with you the rhythm of geological time, where mountains breathe so slowly their movement feels like stillness, and where every grain of sand beneath your feet has traveled distances that span continents and eons. You are part of this ancient story still unfolding, made from the same elements that once sparkled in primordial seas and crystallized in the hearts of long-vanished mountains. Let these peaceful visions of ancient Earth wrap around you like the warm, thick atmosphere that once embraced our planet. Allow yourself to rest in the knowledge that the same forces that created such enduring beauty over billions of years continue their quiet work tonight, shaping tomorrow with the same gentle patience that built every wonder we've explored together. Sleep well, and may your dreams flow like ancient rivers, finding their unhurried way to distant seas.